Hi, this is Mr. Nazarian. Our lesson objectives today. I can recognize volume as an attribute of solid figures and understand concepts of volume measurement. It's a 5th grade standard, measurements and data C3. And also I can find the volume of a rectangular prism, 5th grade standard, measurements and data C5. Okay, we'll start with this. So, some review. This is, you guessed it, a line. A straight line has one dimension, and that dimension is measured in length. We have a rectangle here, and this rectangle is a two-dimensional figure. It is measured both by its length and its width. Something that I know you worked on quite a bit last year was finding the area of a rectangle by multiplying its length times its width, and that gave you the amount of area inside of the rectangle. That area was measured and labeled with square units. Those square units could have been millimeters or inches or feet or miles, but whatever their measurement was, it was in square units. How many of these squares fit into this space? Now what we're going to be looking at are three-dimensional figures, in particular what are called rectangular prisms. And rectangular prisms are measured in their length, their width, and their height. So there's three dimensions that we use when measuring these solid figures. The measurement that we're going to be solving for over the next week or so is finding volume of these three-dimensional figures. So not just the measurement of their line as a one-dimensional, or the amount of area that when we are finding area for two-dimensional, but it is the length, the width, and so how much space is taken up down here all the way up. So everything that would fit inside of this box is the volume. So just like with area we measured in square units, in volume we have a specific unit that measures all volume, and it's in cubic units. Again, these cubic units come in all different shapes. Well, not all different shapes, but all different sizes. They come in, cubic millimeters, cubic miles, cubic inches, cubic yards, cubic meters, and so on and so forth. But they're all measuring the amount of space of how many cubes, or whatever the size those cubes are, that fit into a given figure. So when we look at this rectangular prism, it has all sorts of lines in here. I did my best, but that is 10 long, it's 5 wide, and it's 6 tall, or the height is 6. Each one of these, you can see, I kind of drew them in here, has all these little cubic units. It has all these little cubes that go into this big shape here. And so we could count them all up, right? That might take a long time, and it might be hard to count the ones in the middle here, right? And tomorrow we're going to use some cubes that we're going to be building together and see how this all works. But it takes a long time to count them all up, and in some cases it would be really hard or impossible. So the real question is, how can we find out how many cubic units there are without counting each cube? So a good place to start is what we already know. We already know how to find the area, right? And when you think about, if I'll go back here, if you think about this rectangular prism, a rectangular prism is just a rectangle stack, 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 really tall, right? Here's the rectangle on the bottom, and it keeps going up, keeps going up. So a good place to start is with the base that just has a length and a width, and we know how to find the area of a rectangle by multiplying the length times the width. Another way is we could count them up. But here I just have one layer of these cubic units. So I have 1 here, and 1 here, 1 here, 1 here, and 1 here. I have 5, right? And then 1, 2, 3, 4, 10. And again, to find the volume, we would just multiply the length times the width. And the length times the width would be, let's do this. The length times the width of the base here would equal 50, correct? So, but this figure here, this rectangular prism, is not just one layer of cubic units tall, it's 6. So I'm going to take this base and I'm going to stack it up one more, okay? And so now I took this exact same amount of cubic units here, the 50, and I made a second layer here. So now I've got another 50. And I'm going to take another one, put it here so I have 3 layers, or 3 levels, or 3 stacks, whatever it is that you want to call it. Still not done though. And I got a 4th. Now I've got a 5th. And just need one more 6. So each time I'm layering with another one of these 10 by 5 layers of cubic units. So all I need to do to find out what's in this entire rectangular prism right here is add up each of these layers. So I've got 50 plus 50 is 100, plus another 50 is 150, 200, 250, 300. So, do this here. So, because the height was 600. If the height was only 1, it would have been 50, but the height was 6. So I had to keep adding more of those layers, and now I have 300 cubic units. Okay, is the total volume, means all of these, the cubic units, there's 300 cubes in this rectangular prism. All right, so what I want you to do before we go is take a look at this. Actually, I'll go back here and do this again here. 300 cubic units, and think, is there any connection or any pattern, any observation that you make about these 3 numbers here, the 6, the 10, and the 5, the 6, the 5, and the 10, these 3 numbers, the length, the width, and the height, that could possibly be related to the total volume of this rectangular prism of 300 cubic units. Okay, so we'll take a look at that tomorrow and see if we can find a connection and see what other ways we can, other strategies we can use to solve for volume of rectangular prisms. Okay, see you then.